Hello and welcome. Almost every time I work with somebody who's new to Azure, the question of availability comes up. The how many nines question. So today what I'm going to do is a quick video on some of the design decisions around building for the different tiers of SLA or service level agreement for Azure Virtual Machines. So with that, let's go ahead and get started. All right, so I'm going to pull up the whiteboard here and we'll do a little diagram of what we can expect with the different tiers of virtual machine SLAs. So I'm going to draw a representation of the geography. I'm just going to call this United States, and I'm going to do a few different regions. So region 1 is going to be West US, and then we'll go ahead and do the second region as Central US. And the third one as East US. And in each of these regions, we're going to have different versions of the SLA tiers that you can get with virtual machines. So I'm going to start in the Central US region, and I'm just going to have a virtual machine that is just standalone and is not in an availability set or availability zone or anything like that, and I get a 99.9% SLA standalone virtual machine, so long as it has a premium SSD or UltraDisk. And that's the only standalone virtual machine SLA in the large cloud vendors on the market right now as of time of recording. So the second tier that I can get of SLA is if I use an availability set. An availability set is sort of a logical construct that you define before and while you create the virtual machines to make sure that, as per the variables you set, they have different fault domains, which is inclusive of power, network, and cooling, and make sure that all of those things are separate for the virtual machines that exist within that availability set. And the second is the update domains. So while updates are being rolled out to the different hosts inside Azure, those virtual machines are on different update domains. The idea is if one of them is impacted, the other one or other ones, depending on how many you have in the availability set, will not be impacted. So I'm going to draw a little load balancer here. Excuse my lack of artistic abilities. But the idea with an availability set is that all the virtual machines within it are serving the same application or same service. There's no way to really determine from a cost perspective when you're looking at SLAs whether or not the service was functioning. So that will be looked at to say whether or not both machines or all machines in the availability set were down all at the same time. And if they all were, then it's in violation of the SLA. And the SLA for an availability set is 99.95% SLA. And lastly here, we're going to go and look at the third tier, which is the highest SLA for virtual machines on Azure, which is using availability zones. And zones are physical data centers that are separated within that particular region. An availability set can be in the same data center, but spanning different fault and update domains, or it can be across different data centers within the same region. A region is a collection of data centers or buildings. So that availability set can or cannot be, it's not hard pinned to a certain building. These availability zones are set specifically to a data center within that region. So you are using the terminology pinned to that building. So I'm going to say that I have 3 different availability zones in East US, a VM in each of them. And again, I'm going to do a similar solution using a load balancer. We're just assuming that the same service is being served from all the virtual machines in each of the zones. And the all-up functionality between them is what's used in calculation of whether or not it was in violation of the SLA. Now, what's also important to know here is there is a target latency of less than 2 milliseconds between machines in availability zones within the same region. So when you're looking at the possibility of, with an availability set, the machines being in the same data center, it may be a lower latency, but the target latency between zones is less than 2 milliseconds. So for using availability zones, we have a 99.99 or 4 nines SLA. And that's the highest that you're going to get from a financially backed SLA in Azure for virtual machines. Now, if we want to do more than that, it's not going to be financially backed cross-region, but if we want to look at higher availability, each region within a geography is at least 300 miles apart. It doesn't say how far they are apart exactly, but they're at least 300 miles from a disaster recovery and availability perspective. So when we're considering those design scenarios and we want something with more than 99.99% availability, we can do the same thing in an alternate region. So we can replicate those services to another region and do a similar configuration where, we may run 3 AZs in East US, and we also replicate those and run them out of West US. So that's how we get above the 99.99% SLA. So those are all the 3 different tiers of SLAs for virtual machines that you get in Azure. The single virtual machine standalone, the use of availability sets, which allows you to configure the number of fault domains and update domains, which may be in the same data center, may span data centers. And then finally, the top tier, which is the use of pinning virtual machines to availability zones, where you don't have the ability to control fault domains and update domains, but those are configured for you because they're all housed in separate data centers in that region or on that campus. So I hope this has been helpful, and thanks for watching.